Hello everyone, welcome to Coders Camp. We are at 30th day of October Leetcode challenge and the problem we are going to cover in this video is longest duplicate substring. So the input given here is a string variable s and we have to return the longest duplicate substring in the given input. So let's understand this with an example. So first, what are the substrings given in the input string? There are only 3 characters, so the substring can be B, A, N or AN, NA and BA, otherwise ANA, NAN or BAN. So in this case, these three are the longest compared to the other two sets. So let's start with searching A and A. So do we have two A and A's in the given string? So there is one A and A and another A and A. So this is going to be the longest duplicate substring in the given input and that we are going to return that as our output. So how are we going to approach this programmatically? If you remember, we have solved longest common substring, longest common subsequence and many similar problems with this pattern. So the first idea that stuck in my mind or your mind would be a dynamic programming solution that we have used for longest common substring. So the difference between longest common substring and longest duplicate substring is nothing but in longest common substring there will be string 1 and string 2. For example, consider string 1 as banana and string 2 as Hannah, then we have to find a common substring between these two strings. So ANA will be the common string. But here, in this case, instead of using two strings, we have only one string and we have to find both the substrings in the same string. So the only difference programmatically we face would be both substrings should not start from the same position, which is nothing but if suppose ABCD is one substring and ABCD is another substring, which is nothing but the same word again or the same substring again. So a substring cannot start in the same position. It can override, but it cannot start in the same position. For example, in banana itself, if you start recognizing the substrings, A and A is one substring and A and A is another substring. So here they both overlap, but they both do not start in the same position. So let's go to solve this problem by using two-dimensional DP. So very similar to longest common subsequence or longest common substring, we do have a two-dimensional DP array to compare and fill the common duplicate substring between these two strings and fill the length here. So finally, we would come to the point wherever there is a maximum number. So the 3 is the longest duplicate substring in the given input string, which is nothing but A and A. So it is simpler to solve this way. And as I said, the substring should not start in the same position. Like it should not start from here and here in the two strings. So to avoid that, we are going to fill zeros in the middle diagonal cells, because that will rectify that problem. So by using this technique, you can come up with a solution, but the space is problem here. If suppose the length of the string is 10 power 15, then you need 10 power 15 into 10 power 15 space into the number of bytes for storing the integer variables. So this is definitely not going to be the optimal solution. So how are we going to make it better? So another idea that stuck our mind to always solve a string problem is try. So we are going to construct a try, and with the help of binary search, we are going to solve this problem. So let's start constructing our try based on our binary search. So here the length of our string is 6, starting from the index 0 to index 5. So in this case, any substring that cannot be start from the same position, so it must be at least start from the second position, if at all the substring length, considering the substring length as maximum one. So in that case, our length of our substring would be somewhere from 0 to 4, which is nothing but 1 to 5. So in this case, we are going to find a middle value, thinking that our substring is somewhere in the average length, and try searching for those length substrings in the word again using the try. For example, now the left index is 0 and right index is 5. Now the mid value is going to be 3. So we are going to construct the given word into substrings of length 3. So let's start by constructing from the root node. First B is there, and then from B it is A, and then from A it is N. Ban is our first word. So starting from the 0th index. What if the word starts from the next index? We do a sliding window. From our index 1, we are again going to start constructing our second word of length 3, which is A, and then N, and then A. So again, from third index, we are again going to do a sliding window, which is nothing but NAN. So now from the fourth word, we are going to start next 3 letters, which is ANA. So if you search for A, whether A exists or not, yes, A is exist, then we are going to check the next character, which is N. Then we are going to check the next character, which is A. So this is already present, which means we found one duplicate of length 3. So we keep hold of that. So which means we found some substring of length 3. So there are possibility that this can be the longest, or we can even find any substring of more length. So what are we going to do? We are going to shift our left to 3 and fix our lower bound to 3 and upper bound to 5, and again find a mid value, which is 4. So now we are going to again construct a try starting from the very first character with substrings of size 4 and check whether length 4 substrings are having duplicates or not, and it goes on till we our left and right bound meets. And finally, what is the count we found of the duplicate string will be our output. So this is again a problematic solution because binary search works in an efficient way, which takes log n time, but to construct try every time to each and every length, it is going to take k into log n time, and again searching it would take another n time. So that is again going to take more time to construct try for every possible length, because the maximum length of a given string can be 10 power 15. So in this case, we have to go for even more better solution. So the best solution for this problem would be rolling hash or Rabin karp algorithm. So before getting into how this algorithm can help to solve this problem, let's go for a quick overview of what is rolling hash problem. So rolling hash problem is generally devised to find any pattern matching in a given input string. For example, you want to find this pattern AAB in a given input string, then you have to pick each character and compare. There is a, and then the last character differs. So again, it is going to start from the second character C, the third character differs, and again starting from the third character, and it is going to take infinite time. So this is going to be a tedious process. So how are we going to optimize this? By using hash values. So we are going to construct hash value of substrings that match this length. For example, let's consider A is equal to 1, B is equal to 2, and Z is equal to 26. So we are going to assign each character a value. So in this case, AAC is going to represent it as 111 plus 3, and AAB is going to represent it as 111 plus 2. So it is going to first check the length of this pattern, and the length is going to be 4. So it is going to take substrings of length 4 from the string 1. So the length 4 is AAC. It is going to map and check whether hash of AAC is equal to hash of AAB. No, they are not equal. So in this case, this can't be the same pattern or string. So it is moving ahead to the next one starting from the second A, and it checks AC is hash, and then ACA is hash, and then so on. It keeps checking its length, and then finally it checks AAB. Yes, it matches the hash. Once it matches the hash, it is going to check character by character whether A, and B matches or not. So why? Because in some cases, if suppose the string is AD and another string or the pattern here is BC, they both share the same hash. So they both gonna share 5 as their hash value. So in this case, they are not equal. Again, some anagrams also share the same hash. For example, if ACA is one word and CAA is another word, they both gonna share the same hash value. So in this case, we cannot simply go for this method. Instead, we need some powerful hash method to identify the characters. So here we are going to introduce the exponential format to represent position of each character. So how are we going to do that? So to indicate the position of each character, we are going to identify its position based on tens, hundreds and thousand values. For example, how do we represent a binary to decimal value? So if there is a 1101, then we'd be multiplying 10 power 0 because it is in the 0th position, and then 10 power 1, and then 10 power 2, and then 10 power 3, and it goes on. Same way, you can represent these characters by, for example, if A is equal to 1, B is equal to 2, C is equal to 3, then AC is going to be represented as 1 into 10 power 3 plus 1 into 10 power 2, 1 into 10 power 1 and 1 into 3 into 10 power 0. Why 3? Because C's corresponding value in alphabet is 3. If this is complicated, in the given example, A and A is our substring in banana. So this is going to be like 1 into 10 power 3. N is 14th character, so 14 into 10 power 2, and A is again 1 into 10 power, this is 2, 1 and 0. So this is how we are going to represent the characters. So this also not necessarily have to be 10. It can be 26 or 31 or any value as you like. Because since we have 26 characters, we can represent them in the format of 26 power 2, 26 power 1 and 26 power 0. Or since you don't want any even numbers, you can go for an odd number which is the nearest prime number to 26. Again, you can represent it as 31 power 2 and so on. So again, there comes a problem. If we try to represent them in this format, then it is going to cross the integer limit or long limit in our coding. So in order to shorten the values, we are going to do modulo of some prime number to reduce the value. So let that be 31 or 113 or however you want to be. For example, if we do a modulo with 113, then all our values will be shortened up within 100 or within 113. So in that case, it is easy for us to compare the hash value of two strings. So this is the overall concept of rolling hash. So they will compute hash value of each string of certain length and compare the hash value whether that matches any other hash value in the given input string. And if it not matches, it is going to check for the next string. Not matches, still it is going to find whenever it matches. When it matches, it is going to check character by character. So we are going to get the help of this technique plus our binary search to get an optimal solution. So let's see how exactly we are going to implement it. So as I said, we are first going to use a binary search technique. Now left is equal to 0 and right is equal to 5. So the mid value is equal to 3. So we are going to take hash value of substrings of length 3 from banana. So now the first string is going to be BAN. So this is going to call the hash function to calculate its hash. So this is going to be 14 into, let me use 31, the prime number, to calculate the hash value. 31 power 0 and 1 into 31 power 1 and 2 into 31 power 2. So this would come around 1967. So now we store this in a set. So now our set is going to have 1967 and then calculate the next set of hash, which is for A and A. So instead of again doing the same process repeatedly, we have a shortcut to find the hash value of the subsets easily, because as we know, the length is going to be constant, that is 3. So 31 power 0, 31 power 1 and 31 power 2 is going to be the same for all the characters, just that the front values change. So here what are we going to do is we are going to remove B and add an A to the substring. So this AN is going to be same as well. So what are we going to do? We are going to subtract the value of the leftmost character and then add a value of the next character, which is nothing but 1. Why we add only 1? Because anyway it is going to be the rightmost character, and the rightmost character would always have 31 power 0. So 31 power 0 is anything power 0 is always 1, so it is not going to be a matter. So whatever character we gonna add at the last will be, its value will be added to the previous value, and the value of the very first leftmost character will be deleted from the previously calculated hash value. So the hash value of ANA would be some 1395 and NAN would be more than some 2000. So there comes again ANA. So when we calculate the hash for ANA, that will be again 1395. So when we try to store that in a set which is already exists, which means we found a duplicate substring of length 3. So what are we going to do? We are going to save in a result. So far the duplicate substring we found, its length is 3. So now we get back to our binary search. So we know there we found a duplicate value of length 3. So it can be 3 or more than 3. So in that case our left bound will be switched to 3 and right bound will be switched to 5 again, and new mid value will be calculated, and again all the hash for new mid will be again calculated by using this way, stored in a set, and if it found a match then it is going to alter the result. If not, what is there in the result will be returned. So yes, this is the overall concept of how we are going to implement longest duplicate substring using rolling hash and binary search, and this is going to work in big O of log n log n time complexity. So this login is for binary search, and another login is for the sliding window for each and every sliding window for each uh, m, the mid value we found, and n is for n is nothing but n times we do the number of times we calculate the mid value. So yes, hope I made sense. So let's go to the code now. So here's the code for this problem, and before getting into the main method, let's see the hash and next hash method. So this is nothing but a method used for us to calculate the hash value of any substring we pass onto it. So as I said, we are going to have 31 as our number. So for each character, we take the character's value and multiply it with the previous value and multiply it with 31. So the number of times the position is, we multiply 31 that many times just to compensate the power. So the next hash method is to, once we find the first substrings, for example, if 3 is the length of mid, then if we find the first substrings hash, then rest of the substrings hash will be easy. We are going to negotiate the left side value and add the right character's value. Same way, once we find our new mid is equal to 4, the first hash will find the first substring's value, and then the rest of the strings will be found by next hash. So this is it for this method, and here comes our Rabin karp. So what are we going to do here is, as I said, we are going to declare a set, and in that set we are first going to calculate the hash value for the first substring of length we found. Here length is nothing but the mid value we pass. So once we find that, we are going to add that to our hash. So after that, we are going to iterate for the rest of the string, and for each substring of length we pass, we are going to calculate the next hash value by using the next hash method. So every time we find the hash value using next hash, we are going to update that in our set. We are first going to check whether our set is containing that or not. If it is there, then we are going to save that substring from that length to the other length. The current substring will be saved. or return to the main method. If not, we are going to add that value to our set and continue our search. So coming back to our main method, as I said, we are going to set the values of left and right to 1 and length of the string here, and a result variable is to hold our result, which is the longest duplicate substring in the given input string, and we calculate the mid value and call our karp method with the string and the mid value. So as I said, the mid value is going to be the length of the substring for which we are going to find our hash values. So if the returned length is not is equal to 0, which means we found some duplicate substring of the calculated length, which means we have found a duplicate substring of calculated length. So obviously the result is going to be either that length or can be more than that. So we are going to set our left is equal to mid plus 1. If not, if it is written 0, we did not find any duplicate string of that length. So it could be less than what we sent. So we fix the right value to mid minus 1. So once all the loop is done, the result variable will have the result of our problem. So yes, this is it. Let's run and try. Yes, so solution is accepted. Let's submit. Yes, our solution is submitted, and this is 89% faster than the other Java solution. So thanks for watching the video. Do try out on your own, and also observe what is the other solutions after submitting your solution. So hope you like this video. If you like this video, hit like, subscribe, let me know in comments. Thank you.